Scientists have discovered that space dust is contaminating Earth's atmosphere, raising concerns about its impact on climate, weather, and air quality. Each year, an estimated 5,200 tons of extraterrestrial dust particles enter Earth's atmosphere, originating from asteroids, comets, and interstellar debris. Researchers have found that microscopic space dust particles are accumulating in the upper atmosphere, where they interact with Earth's natural atmospheric processes. These space dust particles are primarily composed of silicates, iron, magnesium, and carbon-based compounds, similar to those found in meteorites. Scientists used high-altitude weather balloons, satellite observations, and deep-sea sediment analysis to track the origins and effects of this extraterrestrial dust. One concern is that space dust could influence cloud formation, altering the way clouds reflect sunlight and regulate Earth's temperature. Some researchers believe that space dust particles may serve as nuclei for ice crystal formation, potentially affecting storm intensity and precipitation patterns. Observations suggest that these particles linger in the mesosphere and stratosphere, where they interact with ozone, aerosols, and greenhouse gases. The presence of space dust in the stratosphere could have a long-term effect on climate by modifying heat absorption and radiation balance. Some scientists theorize that space dust particles may contribute to the formation of noctilucent clouds, which glow in the upper atmosphere during twilight. Unlike volcanic ash or industrial pollution, space dust originates from cosmic bodies and continuously replenishes itself through meteor showers. A significant portion of this extraterrestrial material arrives on Earth through meteorite disintegration, releasing fine dust into the upper atmosphere. Space dust may also transport exotic minerals and elements, some of which are rare or non-existent in Earth's natural geological formations. Spectral analysis has revealed traces of rare isotopes, including helium-3 and cosmic dust grains, which differ from terrestrial mineral compositions. Another concern is whether space dust introduces microbial life or organic compounds, potentially influencing theories about how life evolved on Earth. Some scientists propose that certain complex organic molecules found in space dust resemble prebiotic compounds necessary for life formation. Space agencies like NASA and ESA are investigating whether this dust contains carbon-based molecules that could provide insights into the origins of life. There is also speculation that large-scale space dust accumulation could affect satellite communications and atmospheric conductivity. Scientists are analyzing whether the dust's interaction with Earth's magnetosphere influences the ionosphere, where radio signals and GPS systems operate. Meteor showers, which peak at certain times of the year, increase the concentration of space dust, leading to temporary changes in atmospheric conditions. Some meteor showers, like the Perseids and Leonids, deposit higher amounts of dust, altering the upper atmospheric density for short periods. Researchers have also found that space dust contributes to long-term accumulation in polar ice cores, where it becomes trapped for thousands of years. By studying ice core samples, scientists can trace how space dust influx has varied over millennia, providing clues about past cosmic events. There is also growing interest in whether space dust plays a role in long-term climate cycles, possibly influencing global cooling or warming trends. Some atmospheric models suggest that large-scale dust deposition could contribute to minor temperature fluctuations over geological timescales. Although space dust is naturally occurring, human activity, such as satellite launches and space exploration, may be increasing its concentration in the upper atmosphere. Deorbiting satellites and rocket launches release metallic particles and debris, adding to the mix of natural and artificial dust in space. Scientists are monitoring whether increased human space activity alters the composition of extraterrestrial dust that reaches Earth. There is concern that artificial space debris may interact with naturally occurring space dust, creating unknown atmospheric effects. The study of space dust contamination is crucial for understanding how celestial materials interact with Earth's environment and ecosystems. By analyzing space dust particles collected from the atmosphere, scientists hope to better understand planetary formation processes and cosmic material transport. In some cases, space dust carries nanodiamonds and other high-energy minerals, offering insights into how materials form in supernova explosions. One of the biggest questions is whether long-term accumulation of space dust could gradually alter Earth's atmospheric chemistry. If space dust contains unique chemical elements, it may contribute to the formation of new minerals in Earth's crust over time. The presence of space dust in the upper atmosphere may also influence the behavior of Earth's protective ozone layer. Some studies suggest that dust particles could serve as catalysts for chemical reactions involving ozone-depleting substances. Unlike volcanic ash, which settles quickly, space dust can remain suspended in the atmosphere for extended periods. Certain types of interstellar dust grains contain high levels of radioactive isotopes, which could have subtle effects on radiation levels in the upper atmosphere. Although space dust is unlikely to pose direct health risks, scientists are studying whether long-term exposure has any atmospheric toxicity effects. Some researchers are investigating whether space dust affects atmospheric circulation patterns, potentially influencing jet streams and wind currents. There is growing interest in using space dust as a natural tracer to study interplanetary material movement and the history of solar system evolution. Advanced telescope observations have detected similar space dust compositions around exoplanets, suggesting that dust transport is a common cosmic phenomenon. Understanding space dust contamination could provide clues about planetary habitability and the potential for life on other worlds. By analyzing how space dust interacts with Earth's atmosphere, scientists can refine models for atmospheric conditions on Mars, Venus, and exoplanets. Some researchers believe that studying space dust may help predict cosmic weather events, such as increased meteoroid activity or interstellar dust streams. If space dust continues to accumulate at increasing rates, it could gradually alter the balance of Earth's atmospheric chemistry over millions of years. There is ongoing debate about whether space dust should be classified as a natural pollution source or a fundamental component of Earth's cosmic environment. Future missions may involve collecting space dust directly from the upper atmosphere to analyze its properties in greater detail. NASA's high-altitude aircraft and balloon-based sampling systems are already gathering extraterrestrial dust for laboratory analysis. If space dust is found to influence climate, it may become a new factor in long-term climate prediction models. Some scientists propose that space dust accumulation could have played a role in past mass extinction events, influencing atmospheric composition. This discovery raises broader questions about how Earth constantly interacts with space, shaping both planetary and cosmic evolution.